Welcome to lesson 4 on union and intersection. So this lesson really is just about the notation. I think that you already kind of know these things that we're going to talk about, and we looked at them in the last section, but I'm going to put the proper set notation to them now. So just as a quick reminder, we have seen that sets can be disjoint or they can overlap, right? We know that we can have completely separate circles or we can have circles that overlap. We know that disjoint sets represent data that are considered to be mutually exclusive. So mutually exclusive are data sets that have nothing in common, but we also have terminology for overlapping sets, okay? So when I have sets that overlap, you can have a union or you can have an intersection, okay? So the intersection of two or more sets is the elements that are in common between the two sets. So we use the symbol, this is it represents both A and B. So the way that I actually think of it is if I'm writing it, it's like saying A and like writing an A but not crossing it for and, if that makes sense. So A and B looks like A and B. So those are the things that are in both A and B. Okay, so when I look down here at my diagram, this part in here where we had the overlap, that one is maybe tough to see. I'll give it a different color. This overlap part here is the part that represents A and B. Okay, so that is called the intersection. The union of two or more sets is all of the elements that are in one or the other or both. Okay, so it's an either A or B, and we use this notation here for the A union B, so that can be just in A, just in B, or in both, but it's in one or the other, or in both, okay? So that's union and intersection. So if I look at the sets where A is 1, 2, 3, 4, 5, 6 in this first example, and B is 2, 4, 6, 8, 10, 12, we're going to use set notation to write the union of A and B, okay? So the union of A and B, so I would say A union B, so that means A or B. So I want to list all the things that are in one or the other or in both, but I don't want to list things twice. Okay, so I've got the numbers 1, 2, 3, 4, 5, 6, and then I also have 8, 10, and 12, right? So the number 1 is here. 1, 3, and 5 are only in A. 2, 4, and 6 are also over here, and then I have in addition 8, 10, and 12. The intersection of A and B would be A and B. So those are the numbers that are in both A and B. So I can see that I've got 2 and 4 and 6 in both of them. So the intersection of A and B will be 2, 4, and 6. Okay, we also have something called the relative complement. You can think of it as A minus B, and we write that like this, A given B or A minus B. So think of it of everything that belongs to A, but not to B. So if you were to write down the A set and then take out the things that are not in B, right? So A, take away the things that are in B. So if I take the set A, 1, 2, 3, 4, 5, 6, and I take away the things that are also in B, my A given B set is, so I would take out the 2, 4, 6, and I would have 1, 3, and 5 as my A minus B, my relative complement. Okay, let's look now at this deck of cards. So if you draw a card at random from a standard deck of cards, determine the following. We're going to use set notation wherever possible. So describing the set, so C, so we're just going to go through this because we'll use cards a lot. C will be clubs, S will be spades. Okay, if you're not familiar, these are the clubs. These are the spades. The diamonds are these guys. And these are the hearts. Okay, we also have face cards. That's these guys here. They're the faces. Okay, so D is diamonds. H is hearts, F is face cards. Okay, this will become important when we do probability. We'll deal with them lots. So the number of clubs. So how many cards are there? So if you're not familiar with the deck of cards, there are 4 suits, 13 cards in each suit, total of 52 cards in the deck. So the number of clubs is 13, the number of spades is 13, the number of diamonds is 13, the number of hearts is 13, and the number of face cards is, if you count those up, there are 3, 6, 9, 12 face cards. Okay. Now, this next part is maybe not worded the best, but what I really want in here is I want you to tell me the number of cards that are in the union of spades and face cards. Okay, so spades, union, face cards. So that means, remember that means or. Okay, so how many cards are either a spade or a face card or both? So if we think about, well, that would be, here's my spades, and here's my face cards, and I just don't double count them. So I've got 12 and 10 makes 22. Okay, how many would be in the intersection of S and F? So S and F, the intersection. So how many spades are face cards? So if I look at my spades, I can see that just these 3 here are my face cards. So there are 3. All right, let's look at another example. So you survey 34 people at the gym. You learn that 16 people do weight training 3 times a week, 21 do cardio 3 times a week, and 6 don't fall in either set. They train fewer than 3 times a week. Okay, and I've got a total of 34 people. I'm going to draw a Venn diagram and then use set notation to answer some questions. So this is very similar to what we were doing before. In the last section, we're just going to use proper set notation. So here's my universal set, which will have my 34 people that I surveyed at the gym. I've got weight training, and if I add together my 16 and 21 and 6, I can see that that is more than 34, right? So 16 and 21 and 6 adds up to 43. So I've got too many responses, so the difference is my overlap. So I've got people who do weights, 1 circle, and because it adds up to more than my total, I know that I've got overlap. My cardio is here. So I've got 9 people who must do both. My weight trainers, there's 16 of them, so that makes 7 people over here in the weights. Total of 21 people doing cardio, so that means that I've got 12 people over here just doing cardio, and it tells me that I've got 6 who do nothing. Okay, so to answer my questions using proper notation, how many people weight train and do cardio? So the number who do weights and cardio, so that's the intersection, is 9, right? B, how many people do either weight training or cardio? So weights or cardio, that's the union. So that would be all of these guys in here. So 16 and 12 is 28. Okay. One last thing to look at, it's called the principle of inclusion and exclusion. So there is a formula. If you're a formula person, I'll be honest, I don't love the formula. I'll show you how to use it, but I usually kind of just use that idea of adding them up and subtracting how many are too many. But it says in a group of 100 people, 72 can speak English, 43 speak French. How many speak only English? Only French. So what this is saying is, if I have 100 people, it's saying that the number that can speak either English or French, because everybody speaks one of those languages, is 100. If I'm using set notation, I'm going to do a Venn diagram in the end too, and you'll see that's maybe easier. 72 speak English, so the number who speak English is 72. 43 speak French, so the number who do French is 43. How many can speak English only? How many can speak French only? How many can speak both French and English? Okay, so in this formula, I'd be able to figure out the number that speak French and English. Okay, so if I use my formula, and I'd kind of make it so it would say the number that speak English or French would equal the number that speak English plus the number that speak French. Got an extra bracket in there. Subtract the number who speak both English and French. So if I plug in my numbers here, I've got 100 is equal to 72 plus 43 minus x, because I don't know what that is. And if I want to solve for this, 72 and 43 is 115. Well, and I would move my x over here because it's negative. So I would move my 100 this way and my x this way. So I get x is equal to 100, take away 15, which is 15. So I have 15 people overlap. Okay. So you can do it that way. Like, I don't know. I just feel like that is excessive. Like when we can just kind of think about it and go, okay, here's my Venn diagram. I need to have a total of 100 people. If I add together 72 and 43, that's too many. That adds up to 115, right? So how many too many is that? Well, it's 15 too many because I'm only supposed to have 100 people. So on my two circles, which are English and French, I have an overlap of 15, right? I mean, I did it that quickly instead of writing out that big long formula. So if you love the formula, go ahead and use it. But to me, it seems easier to just do it this way. My number in English, so 72 minus 15 will be 57 out here. And French is 43, so I need another 28 students here. So to answer the questions, because it says how many can speak only English, so the number speaking only English is 57. How many speak only French? The number speaking only French is 28. How many speak both English and French? So French and English is 15. Okay, so that answers my question. So again, you can do it with the formula and it's there, but I definitely prefer the Venn diagram. Okay, you can go ahead and practice those practice questions now. And when you're done, there is a mastery check that you can grab for me and you can do that.